Good morning. Good morning to all the children of grade 9. Welcome back to physics class after a long time. Today, you're going to learn about the new chapter number 11, work and energy. As you all know, in daily life, in a daily routine, we do a lot of work like cooking, bathing, studying, carrying bag, and lots more. But do you know that actually all of these do not fall in the category of work but are activities? These are activities only. In this chapter, we will learn, we will try to learn a lot about work. Work is said to be done only when applied force produces motion, which means that for work to be done, one needs to apply force and motion has to be produced in a body. It means, again, if force is applied on a body and the body moves certain displacement, then work is said to be done. Once again, I repeat, when force act on a body and displaces it to certain displacement or distance, then work is said to be done. So for work to be done, force and a displacement is a must. Without displacement and force, work is zero. For example, come back to the screen. While we are studying, we are using our intelligence, but neither we are applying motion nor motion is caused. So this doesn't fall in the category of work. Likewise, if we are pushing a wall, we are applying force, but reas- that is the reason our hands start paining after some time. But the motion is not produced in the wall. So again, no work is done. Now, if you are playing with your friend and you push him and he falls, this comes in the category of work because in this force is applied and the body is also moving from one place to another place. Let us go through definition of work. Work can be defined as work is done when force is applied which causes displacement in the body. It's in its own direction. Factors on which force depends are work is directly proportional to force, work is directly proportional to displacement. So, work done is equal to K into F into S. If K is a constant and its value is 1, then work is a scalar quantity and it specifies only magnitude and not a direction. Remember this, work is a scalar quantity even though force is a vector quantity which has direction. Work is said to be a scalar quantity. So the product of force and displacement is called work. So when work is said to be done, when force acts on a body and moves it to certain displacement, then work is said to be done. Then what are the expressions to calculate work? Expression for work done against gravity. If we pick or drop anything, it falls to the ground, like a child drops the ball on the ground or a person lifts the bucket from well. So, in this case, work is done in response to gravity. So, in this case, the expression to calculate work is given by W is equal to mass of the body, G is acceleration due to gravity, and H is the height from which the body is falling down. This is obtained by substituting the value of force as mass and acceleration and distance as height. Therefore, the relation becomes W work done is mgh. Expression for work done when the force makes an angle with the direction of displacement. See a person pulling the bag. Here, box is being pulled. W is equal to Fs cos theta. Can you see the angle made between the horizontal and the rope being pulled? Suppose the child is playing with a toy where he is pulling it with the help of a string. Now in this case the force is applied on a string and displacement is caused in it due to force applied. In this case we have to consider an angle also which force makes with the ground or with the direction of displacement, which is usually taken in terms of theta. Theta is nothing but the angle made between the horizontal and the angle with which the rope is being pulled. So expression work for this work becomes W is equal to Fs cos theta. Now the value of the work depends upon the magnitude of angle. According to it, it can be maximum or minimum. Like if angle is 0, then W is equal to Fs cos theta. We already know work done is F into S. But when there is angle between the rope being pulled with the horizontal, the theta cos is nothing but cos theta. We get a cos as in trigonometry in your 10th grade in trigonometry. Cos is nothing but the ratio of adjacent sides to the hypotenuse in a right angle triangle is called cos. Therefore, W is equal to F into S. Because cos 0 is 1, it is proved cos 0 as 1 and cos 90 as 0. So likewise, if angle is 90 degrees, then the work done is WF, that is W is equal to Fs cos theta 90 degrees. Therefore, W is equal to 0. So if any work is done perpendicularly, that is 90 degrees, then the work done is 0. Please note, work done is maximum when theta is 0 degrees. Work done is minimum when theta is 90 degrees. Unit of work. As we know, every physical quantity is measured in physical kind of unit. Likewise, the SI unit of work is joule. We know W is equal to F into S. So 1 joule is 1 Newton into 1 meter. So the unit of work is joule. Force unit is Newton. Displacement is 1 meter. So 1 joule of work is the product of 1 Newton and 1 meter. So it is defined as work is said to be done when 1 joule of work is said to be done when 1 Newton of force is acting on a body and displacing it to a displacement of 1 meter in its own direction. The bigger units of work are gigajoule, megajoule, etc. Let us see the relation between joule, megajoule and kilojoule. 1 gigajoule is 10 power 9 joules. 1 megajoule is 10 power 6 joules. What are the types of work? Now we focus on its types. We have three different kinds of work depending upon the direction and displacement accordance, in accordance with force. As you all have observed that if we kick a ball, it goes in the direction in which it is being kicked. Similarly, if you notice while walking on the floor, one foot pushes the ground backward and the other moves forward. This is how we move, but you are familiar that for walking, running, etc., we need to apply force. The reason is that the ground doesn't allow us to move because of the frictional force, that is, opposing force that comes into play when two bodies are rubbed with each other. Similarly, if the coolie carries the load on his head and moves on the platform, in this case also, Force is applied, but it is at certain angle with the direction of displacement. That is, angle is 90 degrees. Accordingly, we have three different kinds of work: positive work, negative work, and zero work. What is positive work? When force applied causes displacement of your body in its own direction, like pushing of door, kicking football, etc. What is negative work then? When applied force causes displacement of your body in its opposite direction. Example, in case of friction, W is equal to minus F into S. Negative work is done. What is zero work? It is done when force acts on at a right angle, that is 90 degrees to the direction of displacement. That is, W is equal to F S cos theta. When cos theta is, that is theta is 90 degrees, it becomes zero. So work done is zero. Now if you wonder that work done is zero when a person is carrying suitcase vertically in hand, walks in a horizontal direction, this is because the angle between the direction of force and the direction of displacement is 90 degrees. We know W is equals to Fs cos theta. Then cos theta becomes zero, then work done is zero. Similarly, for a body moving in a circular path, the work done is zero due to similar reasons. So with this, we conclude part 1 of this chapter. So you might have learned in this chapter what is work and what are the units of work, when work is said to be done, when work is positive, when work is negative, and when work is zero. So a coolie carrying a luggage, actually, general talking, we say work is done by a coolie, but in physics, work done is zero because the angle between the luggage and the ground horizontal is 90 degrees. So cos 90 degrees is zero. So Fs into zero is zero. So with this, we conclude the part 1 of this chapter. Go through the video twice or thrice until you understand what is work. And in physics, what is work? What are the units of work? Thank you.